Hello students, today we'll be studying last distillation method, and that is fractional distillation method, which I have already studied in your 12th standard for crude oil separation. Right? Now myself Prachi Joshi from Department of Pharmaceutical Technology. Now fractional distillation, or it is also known as rectification. Now where it is basically used? It is used for separation of miscible volatile liquids whose boiling point is very close. Suppose binary mixture છે, એકનું boiling point છે 25 અને બીજાનું છે 25.5, 25.9. So આટલું close boiling point હોય, the separation becomes very difficult in case of simple distillation, right? So fractional distillation is used in this case. Now, what is the major difference between fractional distillation and simple distillation? In case of fractional, we basically use fractionating column. See this. This is fractionating column. In your simple distillation, you don't have this part. What happens is vapor comes out, it directly goes into the condenser and gets collected into the receiver. But in case of fractionation, what happens is this vapor will travel upward, okay, and it will strike, so it will come back. So continuous reheating process takes place, and then it passes here, and then it is converted into distillate and is collected into the receiver. So principle: when a liquid mixture is distilled, the partial condensation of vapor is allowed. Why partial? Because it will strike back and come back. It will strike and it will come back. In the column, ascending vapors. Now what is the meaning of ascending vapors? Vapors traveling upward from the steel is allowed to come in contact with the condensing vapor returning to the steel. We have already discussed this. જે ઉપર જશે વેપર, ઓકે, એ સ્ટ્રાઇક થશે ને પાછી આવશે, એટલે પાછી જે ઉપર જતી હશે એના સાથે કોન્ટેક્ટમાં આવશે, એટલે અલ્ટિમેટલી the vapors will become rich in volatile component. એની અંદર volatile component બહુ જ બધા ભેગા થઈ જશે. Okay, so this repeating heating and condensing process will give you efficient separation of volatile components. The apparatus is almost similar, only we need to study here the fractionating column in detail. A steel in which a liquid is boiled, fractionating column, it is inserted between steel and condenser. We have already seen in the diagram condenser. It is used to condense vapors. Some part of condensate goes back to the column. I already told you this. This is known as reflux, okay, and the rest is obtained as product. The ratio of reflux to product is known as reflux ratio. If the reflux ratio is high, the condensation process is much efficient. Now in the large scale, the provision is made to supply heat at the bottom of the column. At the top of the column, a condenser is attached. A fractionating column has large area for providing sufficient flow condition. At the top of the column is cooler and the bottom, so the liquid stream becomes progressively hotter as it descends, and vapor stream becomes progressively cooler as it rises. Now why it happens? See, at the top of the column there is condenser. જ્યાં condenser હશે એ part cooler હશે, એટલે vapor જેટલી ઉપર જશે એટલી cool થતી જશે, અને જેટલી પાછી આવશે એટલી પાછી એ warmer થતી જશે. Okay. Now, efficiency of fractionation. Now, how to check it is efficient or not? Firstly, length of the column. જેટલી length વધારે હશે, maximum separation થશે. A maximum degree of separation of component is obtained when the length of the column is more. See this. Same diagram you must have studied in your 12th standard. As I told you, reflux ratio should be high. Heat input. Now, it should be under control. Okay. The size of the flame should be adjusted so that the liquid passes over a rate of 1 drop for every 2 to 3 seconds. બહુ વધારે પણ નહીં અને બહુ ઓછું પણ નહીં. Okay, it should be 1 drop every 2 to 3 seconds. Now, fractionating column. Now, what is fractionating column? I already shown you the half of the diagram. In fractionation distillation, special type of steel head is required so that condensation and revaporization are affected continuously. This is known as fractionating column. A fractionating column is essentially a long vertical tube in which the vapor passes upward and partially gets condensed. See this. This will go up, strike, come back, strike, come back. Half of the part will go up. Now, this is another type of, this is packed one. This is packed column. Okay. This is plate one. This is plate one. Okay. A fractionating column is essentially long. Okay. Vapor passes upward and gets partially condensed. The condensate flows down the column and is returned eventually into the flask. We have already studied this. The efficiency is also measured by the theoretical plates. Now, what is the meaning of theoretical plates? See, plate 1, plate 2, plate 3, plate 4. If you go on placing the plates one above the other, the efficiency of separation increases. This is what this part is telling you. Okay, smaller the boiling difference, the greater number of theoretical plate gives you efficient separation. As I told you that, suppose બે liquid છે, એકનું boiling point છે 25, બીજાનું છે 25.5 અને હવે આને simple distillation થી separate કરવું, it becomes very very difficult. Okay, so what we can do, we can arrange this type of plates one above the other, one above the other. So what happens is, according to the heavier and lighter molecules, it will strike and come back. Okay, and because of that also, what happens is, as you increase the surface area, the evaporation and condensation will also, and the cooling will take more efficiently and the separation would be more efficient. Now, fractionating column is divided into two types. Plate column is the first one and second column is packed one. I already explained you this. Now, in plate column, first one is bubble cap column. It is widely used. The second one is turbo grid plate, which is not much used, but this bubble cap column is widely used in the lab. The column is divided into sections by the means of series of horizontal plates. These are the series of horizontal plates, okay, which are mounted by the cap. See, they are mounted by the cap. This is the cap. Each plate carries a number of caps that is secured by the bolt with the plate. It is secured. Now, what is the meaning of secured? It is tightened. Okay. This cap allows the vapor to escape by the bubbling through the liquid. The liquid will bubble, and with the help of this bubble, what will happen? The cap will move little bit up and it will allow the vapor to pass. The same mechanism as that of your whistle of the cooker. Okay, the whistle allows the vapor to get secured in the pressure cooker, but when the pressure is much more higher, what happens is the pressure will be released by the whistle which is kept on the top of the cooker. Same mechanism. Now, working. This working I am explaining. Ascending vapor, the vapor going up, the vapor which is rising from the steel. Still means the flask. Here the flask is attached. Okay, passes through the bubble cap. See, it will pass to this plate. It will pass through this plate A. The vapor will have more volatile component because here it is collected on the plate 1. એટલે અહીંયા volatile component વધારે હશે. Now, this vapor would pass through the liquid on plate B and partially get condensed. Here also liquid is carried, so here also liquid would be there. So again this vapor would pass through the liquid, and some of the liquid get condensed and some will still be in the liquid. So it is known as partial condensation. The heat of the condensation partially vaporizes the liquid. The condensation and vaporization will be repeated at plate C and so on the column. So vapor will travel up, it will strike, okay. Some may come down and some may travel on the upward path. Now here liquid would be there on plate B also. So because of this gets heated and some of the vapor will get condensed and some will travel down. Again the same procedure will take place over here. So one which gets traveled on the top and check upar sudhine pahunchi jase and will go into the condenser will be separated first. Fine, here see. અહીંયાથી ઉપર જાય છે, it will strike, some of the part will get condensed and come back, but some will travel on the top. Some vapor will go and successfully travel on the top. One which travels successfully on the top will pass the condenser and will be connected into the receiver. It will be easily collected, and this is how the separation takes place. Now what is the advantage? The bubble cap plate is effective over a wide range of vapor liquid proportions. It is excellent contact as the vapor bubble through the liquid. There is an excellent contact, means a condensation would take place much more in the faster way. Now what is the disadvantage? The liquid will be held up. Badda plate par liquid thodu rahi jase. Okay, this is one of the disadvantage. Another disadvantage is the need to force the vapor out of the cap. The pressure જોએ છે, okay, એના લીધે through the liquid lead to the large pressure drop through the column. The pressure which would be required will be much more higher, but what happens is when it strikes and comes back, the pressure drops down, and because of that the whole pressure gets dropped down continuously, and there would be a larger pressure drop in summation of that. Now column does not drain. Now the structure is complicated and you can say very expensive. Now second is packed column. Some form of packing is used in the column to affect the necessary liquid and vapor contact. Now there would be kind of glass rings, then glass beads, or you can say stainless steel rings may be used in between. See this kind of. Okay. Now construction. Packed column consists of a tower containing a packing that becomes wetted with a film of the liquid, of course, which is brought in contact with the vapor and the intervening space. What does this mean? એટલે અહીંયાથી તમારું liquid જશે, એટલે અહીંયા contactમાં અહીંયા એક film બનાવી દેશે. This is what it tells you. Now a long fractionating column is necessary when a boiling of the constituent are lying fairly close to each other. But of course, જ્યારે fractionating column is necessary when the boiling point is too near. A short fractionating column is necessary when the boiling point of the constituent differs considerably. Now you don't require every time a large fractionating column. Okay, you can have a short one when suppose a binary mixture has a difference of temperature considerably high, 5 degrees hoy. Suppose 25 and બીજું છે 30 degrees Celsius. So it is 5 degrees, you can say, suppose, it is just an example. It is away. So you can use a short fractionating column. Okay. Now what is the application? Packing must be uniform so as to obtain proper channels. If packing is irregular, mass transfer would not be effective. It would be less effective. Okay. Thank you.